Hello boys and girls, welcome back to our little game dev tutorial. I may notice that the audio sounds better, and that's because I figured out how to use the noise suppression in OBS. Anyway, today we are going to write a sprite system, and that's pretty much it. So we're going to create... Oh. Now we're going to need a package, and what the package we're going to need is newtonsoft.json. It is the best package. It is so fucking useful. Now we're also going to create an IO class, so let's call it game IO, because we're lazy. Now this is going to help us with some IO bullshit. Using using system.io, using newtonsoft.json. Now we're going to create some things for serializing and deserializing objects. So we're going to create a public static void serialize. Yes, I spell it with a Z. Go fuck yourself. Object obj string file name. Now we're also going to create some stuff for writing and reading text files. Let's create a public static void write text file string text string file name. We're just gonna do our file equals file.create text file name, and file.write text file.close. And then we're gonna do, for a serialize function, JSON convert dot serialize objects obj. Now this is going to convert the object to a string. Just do var output equals, and then we're just going to do write text file, and we'll just put output. Now we're going to test that real quick by putting, oh right, we got to put file name. We're going to test that real quick in our main by doing gameio.serialize new game. Let's just serialize an entity. Actually, no. Let's new vec2 42069 test us from JSON.json. Folder bin debug, and then we can compile it. And then there should be a JSON file. Here we go. Here we got 420. Oh, that reminds me, we should format it, because see right here, it's all one line. We should have it formatted for readability. I accidentally pressed unmount, my bad. And we're just gonna... Oh. Indented. Now this is gonna make it look nicer and be easier to edit. There we go. See, X 420, Y is 69. Now you're gonna see why that's useful in a bit. So data. Let's create a new folder called Sprites. And let's just grab something from my downloads folder. What's art we can... Oh, let's just use some Kenny NL arts because he's awesome. Let's use this. Now let's create a new method. Oh wait, now let's create a new method. It's called public static t, which means t deserialize objects. Now t just means it's an undefined object. It can be literally anything, like any return type. And then t string file name. We should probably create another method for public static string read text file string file name. Return file dot. Oops. Read all text file name. Return JSON converts dot deserialize objects. Read text file name. Oops. New JSON serializer settings. Then formatting equals formatting dot indented. That's a weird looking line. I don't know why I can't just use constructor. Drink some tea. There we go. And there we go. We got a class for deserializing objects. So let's create a new class called game sprites. Now there's not going to be too much. It's going to be a few strings. So it's going to be a public string file name. And then public, actually, you know what? Let's see, public fect2 origin. Actually, I forgot we're using capitals in this engine. Now this is gonna be, now let's see, and then we're gonna need what else would we need for a sprite? We're obviously gonna need, how about we make a color class? Game color, and it's just gonna be a few bytes. Public byte RGBA. Public color. Alright, we make a default to 255. So the default's white. And then I think that's all we really need. Oh, actually, we should add some collision info. So we should add some info for collision. Public fect2 collision origin, which is where the hitbox will start, and the public fect2 for the collision size. Now I'm going to illustrate what these two are using some MS Paint or Paint 3D. What I forgot, I'm not on Windows, so we use GIMP. No. Fucking white text. Collision origin. So let's have our game sprite on the screen. And we'll scale it up. Yep. Now, collision origin is the little fucking... No, collision origin is... Let's say the collision origin is here. And then we're gonna have... What did I name it? Collision size, which we're gonna color green. And that's gonna be the actual width and height of the collider. Motherfucker. And bitch. And collision height. I don't know. So collision size is going to be the width and height, and the collision origin is going to be where the collision box starts. And then origin, which we are going to color purple, or whatever the fuck this color is. Origin is going to be right here. It's going to be right here, and this is where the and this is what the actual position is, and it's also going to be where we rotate, like where the sprite rotates, if that at all makes sense. So remember this. Collision origin, where the hitbox starts, collision size, size of the hitbox, origin, where the sprite spins and is positioned. That's going to be a whole lot of math later. Okay. So let's go do public game. Let's make a new public. I think that's everything. Let's do public static game sprites from file string file name. And we're just gonna do return JS game io dot deserialize object game sprite. Now this is just gonna make it easy, so we don't have to write this whole line every time we want something. File name. Oops. Now the file name here is just the actual name of the PNG file. Oh, one thing we should write in our deserialize is if not file.exists file name var obj equals activator. Now if there isn't a file name, we just create a new one. T serialize obj file name. Now this will just make it so that if an object is not serialized already and we're trying to deserialize it, we just go ahead and serialize it. Or deserialize a new one. Now it's just, that just makes everything nice and easy for everyone. I'm so fucking tired, holy shit. Okay, should probably delete this now. Wait, am I? Yeah, I'm recording good, because I forgot to record one time. Okay, now that we got our I/O, let's create some Lua functions. Let's create a... where should we go from here? You know, let's give every game entity a game sprite. Public string game... You know, let's just make this private. Private string game sprite. And this is just going to be the actual file name. Because remember, this is going to be a JSON file. Actually, we should probably make this sealed. So we don't try to inherit. We should also make this sealed. So we get public string game sprite. And then let's just go do... Actually, we should get everything a public int sorting 0. We're gonna use this. We're gonna use this later. We don't need this right now, but we're gonna use it in a future episode when we implement sprite sorting. And then let's just make a public static void draw entities. Oopsie poopsie. Wait, do we have a list yet? No. No, what we're going to do is we're going to create a list of game entities using system.collections.generic. Now we're just going to have one list, but later on we're going to need multiple lists to fucking avoid errors, but we're just going to use one list for now. Public static list entity. Entities equals new blah blah blah. And for each var entity in entities var sprites equals entity.sprite game sprite. Actually, you know, we should do this in the window. We'll do this in the window class. That makes much more sense. In game entity dot entities, right. We should make this public. So then we're gonna need system.collection.generics again. Put it up here actually. System.collections.generic, and then we're gonna need a dictionary. Static dictionary. String sprites equals new sprite. And then we're gonna need another dictionary, static dictionary string. Actually, you know what? Should we just give all the entities a game sprite? Yeah, I think we'll do that. Public static would load sprites. No, this shouldn't be static. We'll just give every entity its own game sprite because it's only a bit of memory. We don't really need to optimize it. Sprite equals gameio dot deserialize object game sprites. That's weird. It's a oh, my bad. Okay. And then in our game window, sprite. And then we're gonna have a dictionary. And this is gonna be our SFML sprites, which is the things we're actually gonna draw. Static dictionary string. Now this is just for optimization, so we don't use a shitload of memory. No, this is the sprite file used by SFML. If we're using another graphics library, you just use something else. I don't care. Sprites equals new sprite. And then we're just gonna handle if not sprite stock contains key sprite. Now this means, hey, we haven't loaded the sprite yet. If we haven't, sprite dot file name, which is the actual texture file, then we're just gonna do var to do sprites dot add sprite dot file name new sprite new texture sprite dot file name. Now what this is gonna do is this is a list of drawable sprites. If it doesn't contain our entity's file name, then we just add a new one. And then we'll do var sfml sprite equals sprites sprite.file name sfml sprite.position equals new vector2f entity.position.x entity.position.y. And then sfml sprite dot rotation equals entity dot rotation entity or sfml sprite dot origin equals new entity dot origin sprite dot origin. Well, no, we just do sprite dot origin dot x sprite dot origin dot y. Yeah, I think that's all the parameters we need to pass to it. Oh, right, we should get the color. Smells sprite.color equals new color sprite.r .color.r sprite.color.g sprite.color.b sprite.color.a. And then after all that, we do window.draw SFML sprite. There we go. Nice and easy. And then our program, right between clear and display, we do game window.draw entities. Perfection. Oh, another thing we should do is if sprites dot file name dot equals and then an empty string, which means if there's an empty string, just continue. So if it doesn't have a sprite, just go to the next one, because if we try to run this, it'll fucking crash. Let's see. Now we should create a new class. Wait, did we already do this? Oh, we already did implement that. So let's add some sprites. Player.lua, and then we should do load sprites, and then it's gonna be data slash sprites slash soldier. So let's name it player.json, and then we compile this, run it. Ooh. Blah, 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 blah. Oh, right. We need to pass the actual entity. So this... Now remember, this isn't a class. This is just random function. So we need to pass the entity, which will be called this. So we'll just... In the entity... let's see, where is our... Oh, right. What is called public see. Well, let's just do it here. Let's in our Lua API. Where is the? That's odd. Okay, what is erroring then? I don't know what's erroring. Motherfucker. God. Oh, right, because we were calling it here. That made zero sense. Okay, now let's create a Lua function for creating an entity. So let's create public static void load create entity, and then string file name float a, and then float x, float y. And then we're just gonna do script file name, and then we're just gonna do game entity. Actually, did we already set up? Oh, we can just do load from file. Dot load from file. File name. Entity dot position dot x equals x. Entity dot position dot y equals y. Let's see. And we'll just do entity.start.call entity. Oops. There we go. So that's going to call this and pass the entity as a parameter. So then we'll just add that script. Okay, caps locks. Script.globals entity creates equals func, because it has a return type, string floats, and then entity. Oh, we should probably return it. Create entity. There we go. So we're just gonna do entity create scripts. Actually, what's this? Where is this? Scripts. Entity slash player.lua. Now it hopefully will not crash. I think it did. Cannot convert a void. CLR type. Okay. Oh wait, we just maybe. Nope. Oops, we forgot to pass the parameters. And then it says I have started, but it is not. Huh. That's odd. But we already. Okay, it's creating it. But it's not Oh, we forgot to set the... Did we set the sprite? Data set sprites, player.json. Oh, right, we never set the texture. That's why. Here we go, so we got all our bullshit. So then in file name, we're just gonna do data/sprites/soldier1_gun.png. Alright, I realized the problem. The problem is it was looping over every entities, and I forgot to add. I forgot to actually add the entity to the list. So let's go do game c.entities.add. And see, now it'll work. I'm a fucking idiot. There we go. Oh, that's debug text. My bad. True debugging. As we can see, it started. Now let's just do it. Now let's add some updates. So it's just gonna do public static void update entities for each var entity in entities entity.update.call entity. Whoop. Okay, I have updated. Fuck you. Now let's just do something real quick. We're just gonna do this rotation equals this rotation plus 0.1. Now, obviously, we're gonna do delta timing in a bit, but for now, we'll just see. There we go. Now, one thing we should do is we should set the origin properly, and we're gonna use my mouse coordinates for now. We'll add an editor later. Okay, we're gonna set the origin to 1621. This will rotate it around its center. There we go. See? Rotating perfectly. And then we'll just move it so we can see it more. There we go. We're gonna do delta timing in just a bit. Actually, let's use a more reasonable resolution. Let's use 720p. He's spin. Now then, we are going to do delta timing. Now, delta timing is, I think it's the time between frames. So now let's say we get a thing. Oh, we should make this a brush. Oh, it's raining now. Let's say we have a thing, and we want to move it that way. There we go. Now let's say we're running at 30 FPS. It would move, let's put, position plus equals 5, and that's fine if you have locked FPS, which most games probably shouldn't. What that means is if, say, we do the same thing but we have 60 FPS, it would be over here. Now, that would completely fuck up your game logic. However, if we multiply by delta time, so say 5 times delta time, it would move 5 units per second instead of per frame. So then that's 30 FPS, and then the same thing in 60 FPS. It would move the exact same. And that'll stop your game from completely fucking breaking at above average FPS. So let's create a time class. Let's create time. Let's make it static, public static float delta time. Okay. And then we're going to have a then we're going to using sfml.system. And then we're going to get delta time real quick. So we're going to do clock delta clock equals new clock. And then over here we're just going to do time.delta time equals delta clock dot restart dot as seconds. Okay. And then we're going to go on in our Lua API. And then we're going to do time functions. So let's go do time funcs script.globals time delta equals func equals we're just gonna do, we'll just do time.delta time. We should have it always updating. Because if we do that, Lua API.scripts.globals. There we go. We'll just have it always updating. Now what this will do is now instead of just rotating 0.1, we'll just do +1 times delta time, which means it'll let's just do 50. That means it'll rotate 50 degrees a second. So if we update it, see, it's rotating at a smooth frame rate. Do we have a function for locking FPS? I forgot. Yeah. Scripts.globals window set FPS set frame cap equals action events game window dot set FPS cap, and then we're just gonna do now to show you why this is beneficial. We're gonna run this twice. So over here we're gonna do 15, and then we're gonna start it. See, and then we're gonna create another instance of the game. CD. Actually, no, let's just open, because I'm lazy. Oops. Alright, now let's see, we got one instance rotating. This is at 15 and this is at 16. As you can see, they're both rotating at the same speed. Because we multiply by delta time. So that means, despite the FPS difference, it's still smooth. Which is why delta timing is awesome, and why you should use it. Okay. We got delta timing. Okay, let's see. Do we need anything else? I think that's all we should do for this episode. So, yeah. Hope you enjoyed. This was complete bullshit. I am bad at programming. Goodbye.